This video is on producing a data inventory. This is the fifth in the R-Instat series on climatic analysis. An inventory is like stock taking. You take stock of the data you have and what's missing. Data from Niger are used for illustration. They are in the data library. So, open from library, Instat, browse, climatic, Niger, Niger for day. How to proceed depends on the detail you need. We start in ways that are familiar. These data are daily. There is a total of 54,000 days of data. There are 14 variables. The first 6 variables are the station and date information, and there are 8 climatic elements. The first look at the data indicates there may be more missing values in the last elements on sunshine and wind than for rainfall and temperatures. Two familiar dialogues continue this initial overview of the data, and we use them in turn. Just use the initial default settings. This gives a quick visual impression of the data. The graph may be clearer in the R viewer. Here, it can be resized and also saved in a variety of ways. The elements are all seen to be numeric variables, as we would expect. The figure confirms there are more missing values for the last 3 elements than for the rainfall and humidity. The one variable summarized complements the information from this figure. The data are seen to be from 4 stations with roughly an equal number of observations from each. 13,000 days is roughly 40 years, with the data from 1940 to 1980. It is slightly surprising that there are more missing values for the rainfall than the temperature variables. It is often the reverse. Comparing with the figure, this is indeed the case. The summary here shows that up to a third of the data are missing for the wind data. More precision is sometimes also useful. We illustrate by examining the data from a particular station. One way to do this is through setting up filters as we show now. Right-click, choose Filter, and then Filter from Factors. Choose Station and select all the levels. Press Return. This has set up 4 filters. Choose near May and then press OK. The data now start in line 13,119 and the red column indicates a filter is in operation. Return to the Visualize Data dialog. This time for a change, choose the missing button, change the comment to Analysis for near May, and press OK. The results now include the percent missing. For example, it is 5% for the rainfall. Right-click and remove Current Filter. These data are already defined as climatic. We confirm through the column metadata. We have already learned a lot about the data. For more detail, the main inventory or stock checking dialog is on the next menu called Check Data. Use Inventory. The date and station are included in the dialog automatically. Add all the elements and press OK. The figure shows, in red, where the missing data are located for each station and each element. Other layouts are possible depending on your subsequent needs. To illustrate, choose to facet by element. If the file had 20 or 30 stations instead of 4, then the inventory could be for one element at a time. It is sometimes also useful to indicate the time of year of the missing values. With multiple elements, consider just a single station. As we previously set up the filters for each station, this step is now very easy. Choose Data Options and a goddess. Change the plot type and use year DOY plot option. This gives the more detailed results shown. We notice, for example, that the rainfall had some data in each of the years. We will see later that this applied to all 4 stations. Next, some numerical results. Start with just a summary. Tick the omit end so we can explain what it does and press OK. The results show, for example, for wind direction WD, that the first non-missing value was in 1949. With the omit end box ticked, all values from towards the end of 1976 are also shown to be absent. They are not taken as missing, but just when that variable was no longer available. 27% of the data were missing within the 1949 to 1976 period. And there were also 11 complete years where there were no missing values. Removing the filter would give similar results for all the stations. The detailed results give a lot of information. So, we illustrate with just the single element of rainfall. Even here, there are 342 rows of data describing each occasion where there were missing values. For example, at the bottom of the results, Niamey has 2 single missing days in April 1980, and prior to that, the whole month of August 1975 was missing. Now, return to the dialog and swap the day for the month. This option ignores odd missing days and just reports when complete months are missing. This can indicate that some monthly paper records remain to be entered. These monthly results confirm that there are no missing years in the data, as that would need at least 12 consecutive months. Try this to confirm. The final option initially seems ridiculous. Choose all the elements and opt for all 3 options of year, month, and day. Now choose to save the results. This has produced all the details and they are all together, and now within a data frame. So they can be sorted and filtered depending on your needs. You may even choose to export to Excel. Just use File, Export to examine the results there. In R-Instat, as an example, we have filtered to provide the monthly results for Zinda for wind direction and wind speed. This gives a more manageable 16 rows of data. This shows the wind direction was only measured after March 1949 and there was a 2-year gap from the start of 1953. The next video is on the quality of data rather than just what is present. We finish with the first of those options because it also shows the existence of missing values. Try with 2 elements for the 4 sites. Here, the black line is called a rag plot and indicates the presence of missing values in the data. We see the data for Niamey start earlier than the other stations, but a lot is missing in the early years, and there is an impression that the seasonal pattern is different to the later years. Perhaps starting the analysis with the data from 1945 might be considered, but we must stop. This is looking at data quality rather than the inventory.